Subtracting negatives, these models can be a little bit more challenging to think about, to wrap our head around. So definitely reach out if you have any questions or rewatch a video, anything you might need with that. So we're going to do our subtraction. Again, leave the problem as it is. I know we just went over those properties, so we know this is 3 plus 2 because I've shown you that property. We have to convince our students, teach our students that 3 minus negative 2 is 3 plus 2. We want to teach them that property. So we've got our same models that we had before to help show them those properties. So for now, let's just keep it 3 minus negative 2 so that we can show these models. So we're going to leave it as subtraction. All right. So I'm going to start with my 3 chips. Let me just rewrite this so I can point something out. This negative 2, this subtraction of negative 2, that subtraction means I want to take away 2 negative chips. When my drawing right there, I don't have 2 negative chips. And I know this doesn't work the same way that the addition chip model does. It's a different setup. I totally get it. That's why I gave you the warning about rewatching the video, asking for any, reaching out for help, any of that stuff. This 3 black chips represents 3. I want to keep this exactly the same value, so 3, but I need to be able to take away 2 negative chips. I've got to take those away. So I need to put some in my picture in order to take it away. So if I just add these in my picture, I know from the addition chip model that we did over here that value is no longer 3. This value would just be 1. I don't want that in this model. I need to keep my value 3. So let me get back what I had. So when I add a negative 2 chips, I have to add a positive 2 chips. Now that thing has a value of 3. Again, that's because these guys would cancel out and I would just have the 3 positives. Let me just draw that back up there. So again, I want to keep my value 3, but at the same time, I need to take away 2 negatives. So when I put those 2 negatives in the picture, they are partners. The 2 positives have to go. Now, I can take away the 2 negatives. I can take those away. I can subtract those. And what I'm left with, that did not turn out the way it was supposed to. What I'm left with are just the black ones. So I'm left with a positive 5, which I know is the answer. I know that was a little tricky. You might need to rewind the video, but I do want to give you one to try. I want you guys to try 4 minus negative 1. We know the answer is 5. I'll give you another one. The answer is 5. We know what the answer is, but see if you can walk through those steps for that chip model. So go ahead and hit pause and see if you can try this one. All right, let's see how you did. If you haven't tried it, really and truly try this because we know what the answer is. See if you can work backwards and get the answer to work out. So I want it to be a value of 4. So I'll start with these 4 positives. There's my value of 4. I've got that. But I need to take away a negative 1. So in order to take away a negative 1, I've got to have 1 in the picture. When I add it, I have to add its partner, its inverse at the same time. That way the value is still 4. The value is still 4 because these guys would cancel out. I don't actually want to cancel them out, but I could. So I added a negative 1 and its partner. Now I can do the takeaway. I can take that guy away, and I'm left with 5 black chips, so 5 positives. And just like before, you could use a positive and negative sign instead of the colored chips, and you would be completely correct. Reach out if you have questions over that one, because I know it's a little funky. The number line model isn't. The chip model is the only one that's what I think is a challenge. So my number line model would work the same as it has been. Let me get a number line down. We know the answer is 5. I would start at 3. And then I've got 2 negatives. Again, this is supposed to prove that I could just change those to positives. So I would be going, you could write that I'm going left and then left again, which doesn't make a whole bunch of sense unless you were to actually like physically like do the turning around. But you could talk about maybe turn around and go backwards, or left, left. If you want to do left, left, that would be fine too. So you'd be going backwards and then backwards again. Or you could use arrows. There's 1 negative, but then I got to turn around and go the other way again because there's another negative. And I would end up at 5. So we're supposed to show that these 2 negatives really are just a positive. There, that's the whole point, is a picture to prove to students that 2 negatives do make a positive.